One of the big things with additive manufacture and magnesium is the opportunity to reduce weight. The next level of that is how you take that additive magnesium and translate it into the product in an innovative way.
Here we've demonstrated our capability to manufacture a real-world component. All the material that we haven't used around this component is recycled. We don't need a specific size billet, so it's much more flexible and robust way of manufacturing magnesium components.
What we're trying to do is enable the aircraft industry to be able to switch to lighter and higher temperature materials. We're trying to move away from the old style metallic parts with engines, which are heavy, and then switch to ceramic materials, or fibre reinforced ceramic materials, which are lighter and can go to higher temperatures and therefore run more efficiently.
The post-piston uniflow engine has a hot cycle, making it extremely suitable for use of biofuels, SAF, sustainable aviation fuel, and other alternatives. It's already up to 50% more fuel efficient than current gas turbine technology and can reach the 2050 ATI goal of a 50% reduction in CO2 and 90% reduction of nitrous oxide gases.
What we're trying to do at Daptics is basically give each one of these its own unique watermark. And that's important because this thing here is made in the UK to a very, very high standard. But potentially the same form factor could be fabricated by someone else without that same badge of British quality, in which case you've potentially got a catastrophic incident if it fails.
This 3D fingerprinting capability will combat counterfeit ingress, protect revenue, but vitally assure authentic, safety-critical parts in the aerospace environment.
EcoJet is a project to develop and further characterise a more sustainable composite material as a possible alternative to titanium in aircraft engine component manufacture.
So what we're looking at here is the lightweighting of air engine components.
The composite materials developed in EcoJet certainly are potentially much lighter weight and can also offer a much lower embodied carbon in the final structure, therefore sort of at least getting us on the road towards net zero.
Some of the major benefits of this process and applying additive manufacture to this part are the fact that we were able to streamline our operations significantly. We were able to reduce the EDM operations by about 70% and the overall operations were reduced by about 50%.
What it gives us is a brand new powder, the 3D printing which can be local to us and then allow us to machine the engine ready components without any assembly, delivered straight to the customer.
What we're developing here is a carbon fibre wheel. No one has actually successfully qualified one and got one flying yet. So if we get this through and working, then it will be a world first. Composites offer us a much better fatigue performance than, say, an aluminium alloy like they use now. The second element is whole life cost savings. We basically make the thing over the life of its use cheaper.
Our technology developed embeds smart and intelligent algorithms. These can detect the aircraft state and condition, minimizing costs compared to conventional monitoring systems. Ultimately, our vibration health monitoring systems help maintain aircraft availability, minimize maintenance flying hours, the rotor smoothing, and they add an extra layer of integrity and confidence, detecting faults at an early stage to assist with maintenance planning and decision making.
Support tool for the decision-making process in non-conformances.
The problem that it's solving is the rapid communication of defects within your supply chain. Using that app, they can capture what the defect is, they can capture footage, they can capture pictures, they can annotate pictures.
AI Record brings all that together into one place and allows you to use tools such as artificial intelligence and machine learning to make better decisions quicker.
By leveraging off of our leading rotor track and balance capabilities, we've generated a solution to bring the most capable rotor track and balance systems into the onboard space. The project has also involved developing a system solution enabling parallel data acquisition of HUMS condition indicators, rotor track and balance data, as well as raw, unprocessed vibration data, which is a first in this third generation of HUMS system. This unique capability enables HUMS condition indicators to be developed and refined in the ground station environment, even beyond certification of the airborne hardware.
Inception is a revolution in electric flight control actuation.
The biggest thing about Inception is the over 80% reduction in energy usage with half the weight. We are using a standard 28-volt supply, which we believe is the key enabler for move to more electric aircraft.
The things that you can do with that and the things that we are doing with that could save billion tons of CO2.
The RT-TIP track is the only blade tracking system that uses real-time image processing to photograph the blade tips during flight, enabling accurate measurements and good robustness in all weather conditions. We are the only supplier that offers consistent tracking at the tips of the blade. Our technology does not require any special blade markings, preparation or painting. Unlike other tracking technologies, we use diagnostics data collected by the tracking camera to validate system performance for each unique aircraft type.
I'm CEO and co-founder at Intelligence, where we are using a new type of machine learning to help develop materials, chemicals and drugs faster, cheaper and cleaner than ever before.
This is in comparison with a contemporary approach to materials design, which comprises many cycles of trial and improvement to hit upon that right material. The Alchemite's machine learning technology allows our customers to both accelerate and also reduce the cost of discovering new materials.
Lots of our technologies are going onto existing platforms, which means we have to retrofit around existing structures that are there. What we've been able to do with our automation system is bring automated fasteners into that environment and retrofit around either the gantry or the arm robot that's already there. And customers really benefit from this. It's a much cheaper alternative than taking the whole machine down and putting a new one up. But more importantly, it means they don't lose any downtime with regards to manufacturing.
The material is producing MOFs in form factors that allow them to be integrated into systems for the first time. So rather than binding powders together, as has been done in the past, Immaterial makes MOFs as macroscopic crystals. We're developing technology for truly diverse and global applications. Things like soaking up CO2, turning desert humidity into clean, fresh drinking water, purifying and storing hydrogen at reduced pressure, and removing toxic and volatile compounds from air.
What we want to do in this project is come up with a material that has that really high temperature strength, but also prints really well. And this will really revolutionize the ability of additive manufacturers to produce components that are used in these high temperature, high performance aerospace components.
Higher temperature operation in aerospace engines leads to higher efficiency. Additionally, additive manufacturing enables designs of components that are both functional and lightweighted, which again leads towards fuel efficiency.
Thermal engineers are after really accurate temperature measurements.
SCS have developed groundbreaking technology to do just that to a level of detail unprecedented in its field. The data it returns can accelerate the design process validation from months to just days.
All we do is we have a coating, a very, very thin coating, and we get full coverage, high quality data.
You're driving towards a hydrogen economy, then you need to redesign engines and you need to do that fast.
And I think we have the perfect technology to enable this revolution to take place.
TextureJet designs, develops and deploys surface texturing and finishing technologies for the advanced manufacturing sector that allow significant reductions in environmental impact and cost in comparison to current technologies that are available.
Compared to the current legacy techniques, which are sort of your media blasting or your chemical etching, which the industry has a lot of pains with, our process uses just green chemistry, so it's a much safer process and massively reduces your waste.
It's a structural housing for aircraft antennas. Requirement for data is only ever increasing, so you're going to need more antennas, which means they need to be smaller, and it's better for them to be lighter. This project, led by TCS, developed this working prototype, which has been tested with an antenna inside it and the frequency selective surfaces. It's lighter because we've got composite materials replacing metal, but it's also smaller, and it's passed all of the pre-flight qualification tests.
SmartCal is a solution to the subject of calibration. TAO DMS intend to disrupt current practice by introducing innovative software combined with hardware technology.
And our idea is to hopefully revolutionise the way in which SMEs run their internal calibration process.
And it's designed to track and measure instruments and tools as they move across the factory floor.
And this will ultimately enable the reduction of non-conforming product and eliminate a lot of wastage.
The new beam technology, which is baked into our Calibre 3 platform, offers a real step change in terms of capability, and it also offers the ability to produce larger structural parts that are free from residual stress. Additive manufacturing is really great when it comes to looking at buy-to-fly ratio. We can really knock down the amount of waste material. We also offer a substantial reduction in energy consumption in the process, even compared to the state-of-the-art AM processes you see today.
Using 21st century technologies, we're developing systems that will significantly cut the amount of energy needed and also increase efficiencies across whole systems. In this project, we wanted to demonstrate this technology on an aerospace application. We chose brake-by-wire systems and prove the concept and move it through to the next stage of development.
Our world-class power density gives significant weight reduction across the aircraft, in some cases more than 10 kilo per actuator.
Vantage is a deck landing system, so when the drone arrives on location, it will search for the ship, decide how to approach it, and then execute the landing on the deck. This is our full-size landing deck, fitted with a set of infrared beacons. These are invisible to the human eye, but they allow Vantage to execute landings during the night. This will execute the flight as well as land the drone at the end of its mission. Over the next 12 months, we will redesign this with custom electronics, and we will probably shrink it down to a third of its size.
Looking at improving a robot's accuracy through photogrammetry and machine learning. Iona is capturing positional data from the robot's tool, and we're capturing data out of the robot controller as well that is telling us where the robot thinks it is in space. This data is going into a training set that will train the machine learning model to anticipate where the robot will be more inaccurate and where the deflection might be higher. It could make automation cheaper in the long run for aerospace. A system like this is certainly cheaper than a big bespoke machine, so you'd improve flexibility of your cells. It could be retrofitted relatively easily.
The main objective of this project was to develop a methodology that could be used for the characterisation of potential contaminants in superalloy materials.
It is very important for us to understand how our materials behave in certain environments to maintain flight safety. The level of detail that the SIMS and the microscopic analysis gives us a lot greater understanding of what we can do to mitigate any negative effects.
The Magmatics technology is combining a permanent magnet machine with a magnetic gear to make a new machine which is very lightweight. The part of the Phoenix project has been to find further methods to lightweight our already lightweight motor.
The magnetic gear embedded within this motor allows us to achieve extremely high levels of torque density. Not only that, it also provides extremely high levels of efficiency. Normally we have to trade off one for the other, but in this machine we can get both at the same time.
For the last 50 years, the titanium aerostructure market has been dominated by the forging industry, and we're developing a process which will not only be economically viable in comparison to the price, but also a more sustainable way of making those components for the major primes. The driver for our technology, PM-HIP, is to drive down lead time, and drive down cost, and drive down machining of the component.
We developed the hardware and the full stack systems that work in unison with human beings to ensure the products are delivered with the highest quality and safety.
We take a video of the assembly being processed initially, and then we digitize that record. Once we've done that, each time an assembly operator recalls that item to be made, it's compared against the original gold standard.
It's going to help reduce the risk of human error because the system flags up if you're working out a process, and that's going to be a big help.
TRT's motivation for this programme is to better understand how we can use digital technology to inspect components that we have traditionally done in a more manual way.
The power of getting that data will be, we'll be able to put the part into process number 1, process number 2 or process number 3, which again will increase the yield and the rework.
We work with our partner, AdQual, to understand better how we can use digital processes to make the right decisions at the right stage of our value chain to offer the best value for our end customer.
The big advantage that our software delivers for users is really time saved. At the start of the production process, it's reduced time around changing your design for additive manufacturing. A step after that is time around doing your CAM, preparing your toolbar for the given part. That's reduced up to 70–80% in our software thanks to all the little bits of automation. The step after that is during printing, it can reduce production time by up to 60%, and with the final step, reduce post-processing thanks to better surface finish and tighter dimensional tolerances straight off the build plate.
This is a project that's focused on the advanced air mobility sector, on electric vertical takeoff and landing. It's kind of large drones that are going to fly people around. The trajectory for this market in terms of volumes is enormous.
We have a range of experience of different processes, different design methodologies which we feel are really appropriate to productionising high volume rotor blades, and the HALOS project enabled us to crystallise some of those ideas and get them into a working proof of concept that we can take to customers and show what we're really capable of.
Our NATEP project is focusing on the use of discontinuous fibre composites used in high-performance aerospace applications, primarily the use of compression moulding and SMC material itself. We manufactured a demonstrator component within an eVTOL application to keep weight to a minimum, but also reinforce locally areas that need to be reinforced. The main benefits of our process over the traditional approach within the aerospace industry is much lower cycle times, much lower waste, and much lower unit costs.
The purpose of the project was to design new wires for titanium additive manufacturing industry.
The titanium wires that they've been producing are very important in additive manufacturing, and that helps reduce the weight of certain items. Typically, it also reduces waste by something like 80–90% and reduces carbon dioxide emissions, which is a big issue for climate change at the moment.
One of the beauties of magnetic bearings is because there's no contact with the rotating parts, there's no friction and no wear. So for applications where you need high speed for a long duration with low maintenance, they're ideal. They're already used in some oil and gas applications. We wanted to take them into primarily turbo compressors in aerospace. We have a lot of experience designing and manufacturing motors for aerospace, so we know how to make the manufacturing process as streamlined and simple as possible. And we used all of that in Vamba to minimise the winding complexity and therefore making it easier and simpler and cheaper to wind.
Here we've got the Eco Tool, which represents a low power, low cost solution with limitless scale for curing carbon fibre parts. This process requires a lot less energy than your traditional method, about 98% less. And that's because you don't need to put it in an autoclave, but also conforms to all the aerospace standards that are required.
The main benefit of Eco Tool is we can produce large scale components at low power, reduced time, and therefore minimal cost.
We're taking all the advantages of an electric motor and using that in redesigning the propulsion system to put the motor round the outside of the rim.
A rim-driven concept at high power like no other system is able to run currently. We're looking actually to provide up to an over 25% efficiency gain, but there are a lot of other gains in terms of the acoustic performance, and also it's much easier to cool passively, so uses less energy to cool and can get rid of heat a lot faster than a conventional system.
Sealer offers the aerospace market a unique actuation solution. It provides a very high load actuation capability with very minimal and highly efficient power requirements.
One of the benefits of the Sealer actuator is its super efficiency, and then what that means is if we ever have any failure or power outs, we can simply, the power's off, push it back into position, which can't be done with conventional electric actuators.
Our NATEP project was working in conjunction with our partners to develop the process for using AM200 with soluble support,
which can be washed away once the part's been printed, compared with physical support, which needs to be physically extracted from the part. The benefits of using soluble supports are you can print more complex parts,
which you cannot achieve with the current offerings in the ultrapolymer sector.
The support's more easily removed from the part. It speeds up the process of producing parts, and it reduces the risk of damaging parts during the production process.
The NATEP project that we undertook was to develop a thermoformed twin skin panel to reduce part count and to reduce the weight of the overall panel. This project focused on automating that in order to increase the repeatability of the process using automated collaborative robots. We managed to reduce the cycle time by 53% and also increased repeatability and quality of the product.
This has been a real game changer for the business.
In this project, we wanted to increase the operational envelope and safety and adaptiveness of drone controllers compared to cascaded PIDs, which are the conventional way of controlling drones. You're able to take an existing drone platform, retrofit our AI controllers, and gain essentially a more robust and capable system.
The benefits of this project are a flight controller with increased robustness, so for example to wind or failures in the system.
The Luffy AI controller will adapt in real time to the failure or the damage and be able to either continue on the mission safely or safely land.
NATEP project in PASA is improving aerospace software assurance.
And the goal of the project is to reduce the manual effort involved in reviewing software for safety critical systems, so helping the engineers focus on what they're good at and automating as much of the process as possible.
In a manner that is qualifiable and will put customers on an accelerated path towards certification.
One of the benefits to the customers is saving cost,
allowing them to achieve their verification and testing artifacts quickly.
The ODART project took our radar-aware product, which is designed to detect non-cooperative targets in the sky, forward towards certification of that product for use in environments where manned aviation may be present.
So it will detect obstacles such as other drones, light aircraft, trees, cables, buildings.
Ultimately, that means you can operate more drones, you can share airspace with other flying objects, other aviation, and you can be sure that you're going to be safe and resilient in your mission.
The NATEP project, called SmartThread, is a collaboration between Ionics Advanced Technologies and ICE Electronics.
The NATEP programme was designed to create an intelligent fastener for condition-based monitoring of borescope plugs,
which has got a very small footprint, which sits inside a borescope port on a small or large engine. For the first time, this intelligent fastener SmartThread can work directly in situ in an extreme environment. It can work behind the firewall whilst the engine is operating.
No one else has really done this in this environment before.
Tape Extreme is a novel tape. It has the properties of thermoplastic. It's easy to work with, it's easy to lay up, but it really has thermoset capability in terms of high temperature. So that basically means that you can produce those really high geometric parts that end users are looking to manufacture.
We are able to process it in its thermoplastic region, which enables us to use automated manufacturing processes, which will reduce cost and increase rate.
This is a game-changing technology.
The Flights project was a follow-on to our previous NATEP program where we developed a hybrid copper and fibre test system. The Flights project was designed to add a distance to fault capability.
So it can look at electrical and optical systems, scan to see if there's a problem, and then tell you where that fault is. Sometimes on a platform, such as a train or a plane, the faults can be in 100 metres of harness. Being able to accurately know where that fault is and narrow it down to the panel you need to remove saves time, money, and is also better for the environment because you're not replacing larger parts of the system when you don't need to.
E-propulsors need to be tested within a wind tunnel environment. That can be extremely expensive and can be prohibitive in terms of getting these types of propulsion systems to market.
The key benefits of the eKettle project are its affordability to small companies and startups who are looking to gain real flight data on their novel propulsion system but don't have the budget available to go to some of the large commercial wind tunnels. However, the capability would be available to larger markets, including mainstream civil aviation.